Welcome and thank you so much for joining me. So we are looking at Eulerian trails and circuits. Now, to have a Eulerian trail and circuit, it must be a traversable graph. And we talked about a traversable graph is a trail that includes every single edge. So we've got three examples here, and we are going to be looking at them. Now, for it to be a Eulerian trail, it is a trail that includes every edge, but it has two vertices with odd degrees. Whereas a circuit, every vertice must have an even degree. So the first thing I'm going to think about is looking at my degrees of every single vertice. So every single vertice of my first network has a degree of 2. So that means if I go through my network, I'm going to be able to go through every single edge. So let's have a go and see. So we're going from through the first, second, third edge, and going to the final edge. As you can see, our starting and finish point is ending up at the same place. It's ending up at this vertex. That shows you that it is a circuit, a Eulerian circuit, and that's because all of the degrees are even. So we are going to now look at our second example. Straight away with this example, I'm going to look at the amount of degrees I have for each of my vertices. So this vertex here has 2. My next vertex has 2, 2, 3, and 3. So this means that I know it's going to be a trail. So the starting and end point will not be the same. So it's when we have a Eulerian trail, we must be starting on the odd degree and we must finish on the odd degree. So I'm going to be starting at this point right here. So let's work that out. I'm going to travel now. As I'm traveling, we can see I'm going to every single edge once, but my start and finish points both end at where there is an odd degree. So I know straight away that I have a Eulerian trail. Now let's look at our last question here. Now this here, straight away I can see that when I'm looking at my degrees, I've got more than 2 of my vertices that are odd. Because of this, I know that it is not a traversable graph, which therefore cannot have a trail and cannot have a circuit. Now this is your turn. I would like you to pause the video and determine if each of these A, B, C, and D have either a Eulerian trail, Eulerian circuit, or neither. So I'll give you as much time as you need, so please pause and then check and go through the answers. Okay, you should have had plenty of time to check. So the first thing I always think about doing is looking at the amount of degrees each vertex has. So this degree has 4. This vertex has 3, 3, and 4. That tells me that it is going to be a Eulerian trail because it has 2 vertices that are odd. So I'm going to start at one and I'm going to finish at the other. So as I'm looking at my trail, I'm going to be thinking about what way I am going. So I'm first going to be going to the 4. I'll make that thicker so you see. Going to the 4. Then I will move over to my other even degree, around it, again. I'm at my end point, but I've still got a couple of extras, so I'm still not going over. So here I have not gone over any of my extras more than once. So I know it is a Eulerian trail. Let's have a look at question B. So question B here, the first thing I'm going to do again is look at the amount of degrees I've got. I've got 3, 3, 2, 4, and 4. So now I've done this, I know I have a starting point and a finish point. Because again I've got 2 of my vertices that have a odd degree, it has to be a Eulerian trail. It's not a circuit. But I do know it is traversable. So I'm just going to again mark my starting point and my end point. And now I just need to be able to draw my map. So I'm going to start here and go around. Now this is where we need to think about making sure we are going to end at the same point. So I'm going around the loop over to my odd vertice to finish it off. So here I am able to see that it is a trail. Let's look at my C. Again, first thing I do is look at the amount of degrees I have. I have 3, 3, 3, and 3. Now I can have a go and try, but I know that because every single vertex is odd, I am not able to have a Eulerian trail or a Eulerian circuit because it is not a traversable graph. The last one we're going to look at is this one here. And straight away, I can see that I've got most of my vertices even except for 2. Because it's 2 odd, it means I have my starting point and my finish point. So I'm going to start over here, and I'm just going to follow that around. Remember, these circuits and these trails and circuits you cannot go over the same X, but we can go to the same vertex. And again, I get back to this vertex right here. So this shows me again I have a Eulerian trail. So out of all these 4 questions, we had 1 neither and 3 trails. I really hope this is helping you understand what a Eulerian trail is and an Eulerian circuit.